Alright, in this tutorial we're going to go over how to factor quadratics using some algebra tiles. So we're going to start off with a quadratic trinomial, and a quadratic is anything with a power of 2, and then a trinomial is anything with 3 terms total. So kind of thinking backwards from multiplying of your binomials. If you multiply two binomials together, that last section in the previous unit that we went over, factoring a quadratic trinomial, factoring something that is a power of 2 with 3 terms, will give you its factor term that is 2 binomials. So your problems or your setup will start with a quadratic trinomial, 3 terms, like this first example is 2x squared plus 4x plus 2, and you're going to end up as an answer into 2 binomials, and they'll be in parentheses like an x plus 4 times x minus 2, something similar to that. So when you're looking at these with the algebra tiles, your quadratic trinomial is just your total. It's everything that you can count and see. So you have 2 of the x squareds, so we count 2 of the total x squareds there. You have 4x, 1, 2, 3, 4x is total, and then 2 is your constant, 1, 2 is your constant there. So that is what the quadratic trinomial is going to be. When you get it into your binomial form, or your factored, that is where you are looking at the bottom row and then your far right column. So your bottom row in this example is x plus 1. Your far right column is 2x's and a 2. Because when you multiply those two things together, thinking backwards, that is how you get the quadratic trinomial of 2x squared plus 4x plus 2. So again, we're starting off with 6x squareds, 10x's in total in both areas, and then 4 is your constant here. So we're going to factor this by looking at the bottom row and our far right column. Bottom row is 2x plus 2, and the far right column 1, 2, 3 plus 2, 3x plus 2. The algebra tiles make it pretty easy as long as it's set up in a perfect rectangle where everything is balanced and even on the sides. And then you should be able to completely factor everything into binomial form from there.